Several months ago, I did a couple videos on data around masks. This is a quick follow-up. Think of it as some cliff notes from those, with some new data added in since the science is ongoing and understandings continue to be built and improved. So, do masks help slow spread of disease? And if so, how? We looked in one of the previous videos at a couple studies focused on other infectious diseases, studies done well before COVID-19, that suggested that masks reduce the number of virus particles that infected people spread. They don't eliminate spread, but they do reduce it. Why does that matter? It comes back to the R value you've probably heard about. The R value represents the average number of people a sick person infects. If 10 people get sick and 9 of the 10 each pass it to one person, and then the 10th passes it to 2 people, then 11 people got infected from a total of 10 originally sick. 11 divided by 10 is 1.1. That would be the R value in that case. The R value matters most when thinking about the big picture, like what's happening at the level of cities, states, or the country. Here's why. This plot has a series of 30 rows, each made up of 30,000 small dots. The rows represent days, with day 1 at the bottom and day 30 at the top. The dots represent people, so think of these as representing the same 30,000 people on each of 30 days. We can use the value of R, the average number each sick person infects, to predict how many people will have gotten the virus after each day, assuming we start with just a single sick person on day 1. Red dots will represent sicknesses. Here's the prediction with an R value of 1. Here's 1.1, 1.2, 1.3, 1.4, and 1.5. Notice that small changes in that R value, just tenths of a point, can have big effects on how quickly disease spreads. And this is the main justification for masks, or social distancing, or washing your hands, or reducing how much you're out around others. The bottom line, again, is that small changes in that R value can have major effects. From a glass half full perspective, that means that anything you can do to help reduce the spread, like wearing a mask, even if the reduction is small, can potentially have a big effect on a lot of people. A recent paper from just a few weeks ago reported a model predicting that if 95% of people across the country wore masks, the number of US COVID-19 deaths by February 2021 would be roughly 85,000 to 170,000 fewer than if mask use continues at recent levels. So much of this is based around the idea of exponential growth, which is a phenomenon that isn't always intuitive. It's often not easy to grasp the power of exponential growth, even for me, and I think about it and work with it fairly frequently. But regardless of how easy or hard it might be to comprehend, the reality is it can be incredibly powerful. Hope that's helpful. If so, feel free to like and share this video. And if you want a heads up when future similar videos go up, subscribe to the channel and make sure to click the bell icon to choose to receive notifications.